Trying something a little bit different. And today I want to talk about prime factorization and specifically reducing fractions. So prime factorization is one of those things we really do in 4th, 5th, 6th grade, and we don't really touch it too much after that, and we don't get to explain how cool prime factorization is. And this is just one of the many things you can use it for later on. So let's get started with some examples. If you have something like 51 over 68, and you're trying to reduce these fractions, because my math students know that if you don't reduce fractions in my class, you don't get full credit. So you always reduce fractions if you can. And 51 over 68 at first might seem like, I don't know what to do with this. And prime factorization can actually really help in these situations where you might not see a common factor between the two, right? Because that's how we teach you to reduce fractions. A number can divide both the top and the bottom. Right now, it's hard to see a number that can divide the top and the bottom. So what we could do is we could just go and factor them out separately. So 51, if you look at it, when we did divisibility, the digits 5 and 1, the digit sum between 5 and 1 equals 6, which means 3 can divide this number. So let's divide 51 by 3. So we get 3 times 17. And then once you have that, you can just kind of go to the bottom and you see that 68 is an even number. So my first instinct is to just pull out a 2 out of this. So boom. Now what I do notice is once I half it, it's an even number again, which means a 4 could have just went into it to begin with, or I could just half that. So now 68 is 2 times 34. Let's take out a 2. So now you have 2 times 2 times 17, right? So I have all this stuff on the bottom. Aha! So now we see this 17 that was hiding in here as a factor between the top and the bottom. We cancel those. And we're left with 3 on the top and 2 times 2 on the bottom. So this reduces to 3/4. Pretty cool. So another example would be something like this. 123 over 410. All right, so again, numbers are getting a little bit bigger. It's getting a little harder to see some common factors in here. But we know that same trick as before, 1, 2, 3 at the top. That digit sum, 1 plus 2 plus 3, that's going to give me 6, which means I know 6 is divisible by 3. So 123 is divisible by 3. If you just imagine the long division, we see that the top, the numerator here is going to be 3 times 41. So now we look at the bottom, 410. Well, obviously I'm going to want to divide 10 out of that, so it's going to be 41 times 10. Now we see that 41 is a common factor. You can cancel those immediately. So now the answer would be 3/10. It's a little bit faster, in my opinion, than checking to see if something divides both of these, where 41 was that prime number that would have divided both of that. But during a test, I wouldn't want to spend all my time checking all the numbers up to 41. This one's kind of an easy example because the moment you pull the 3 out of the top, the numerator, you do see that 41 just popping out at you. So sometimes you only have to just factor out the top, even if you don't know if something is going to divide out, and you can start to see right away, oh yeah, there's a common factor here. Another example would be something like 134 over 335. Okay, this one, the numerator, to me, is even. All right, factor out the 2. So let's do that. Then 134 becomes 2 times 67. On the bottom, there's a 5 at the end. So obviously, I'm going to want to divide out 5. So 335 becomes 5 times 67. Another nice example, 67 cancels out. We have 2/5 at the end of the day here. Great. This method is really useful. Instead of like the traditional way where we're telling you, look for the number that divides the top and the bottom, just go and divide stuff out from the top and the bottom separately, and then just see what's left over and cancel out the common factors in the numerator and the denominator, and just collect what's left, rewrite the fraction. Usually a lot faster for me. Everybody's different. So let me show you one more example where maybe at the end you might want to just go back and collect all the ones you didn't cancel out. So here's one. Ready? Boom. So this one is 1,272 over 1,325. So a big fraction. Yeah, like there's a couple things I want to like divide out right away. Again, I don't need to sit here and see if something divides both the top and the bottom. I'm just going to go dividing stuff out of, like pulling factors out of the numbers separately. So for the numerator, it's an even number. So I'm going to pull out a 2. That gives me 2 times 636. For the denominator, I see a 5 at the end. So I'm going to pull out 5 and see what happens. So now that turns into 5 times 265. All right, Cool. Now the next step would be, well, the numerator, I still see an even number. But instead of having that number, in my head, it's easier for me to just see it, and I see that 3 would just go into each of the digits nicely. So I'm going to divide that 636 by 3. So on the top, now I have 2 times 3 times 212. In the denominator, I'm going to have another 5 over here. I can pull that out. So on the bottom, that turns into 5 times 5 times 53. We're getting somewhere now because the denominator at this point is completely factored out. This is 53 is a prime, and this is my prime factorization. Pretty cool. So now I'm going to revisit the numerator. I see that there is a 212. That's an even number. All right, now let's pull out that 2. So the numerator is going to have 2 factors of 2. So it's going to be 2 times 2 times 3 times now 106. Starting to see something. Because I know that if I pull out another 2 from that 106, which is an even number, so I know I can pull out a 2, that's going to turn into 53. This is awesome. So now the whole thing is going to turn into the numerator. I have 3 factors of 2, right? 2 times 2 times 2 times 3 times 53. Cool. The denominator was 5 times 5 times 53. Super awesome. 53s cancel out right away. Now I'm just going kind of simplify that back up. So on the top, 2 cubed times 3. Okay, that's 8 times 3, which is 24. On the bottom, I have 5 squared. That's 25. That big evil fraction in the beginning, 1,272 over 1,325, okay, ended up being 24 over 25. I don't know about you, but I didn't want to check to see if some number could divide into both of those. So pretty cool. In the future, I do plan to give you more insight into why we learn prime factorization and how useful they could be. So yeah, stay tuned for that. All right, go reduce fractions. Bye.